This is the step-by-step key for the ALT 7 review. The first thing we're going to do is we're going to rewrite the expressions in rational exponent form. Remember that when you're looking at the square root of x with a root of n and a power of m, you can rewrite that with x to the m over n power. The power is the numerator, the root is the denominator. So our first one, 2a in parentheses to the 1/4 power. Number 2 will be 8 to the 1/2 power. Number 3, we're going to put 5x in parentheses. We've got a power of 1 and a root of 2, so that's 1/2 power. Number 4, we're going to have a 10 to the 7/5 power. So the power goes on the numerator, root goes in the denominator. Number 5, we've got x to the 2/3 power. Number 6, we're going to have 3n in parentheses again. Make sure you put the parentheses around 3 in the n to the 1/2 power. Number 7, we're going to have 2x and y all in parentheses. We've got a power of 3 and a root of 2, so 2xy all to the 3/2 power. Number 8, a to the 1/6 power. And number 9, we've got negative 5b in parentheses, all to the 4/5 power. For part 2, we're going to start in rational exponent form, and we're going to rewrite in radical form. So 2 to the 1/3 power is going to become the cubed root of 2. Number 11, you're going to have 4x under the radical, so it's going to be the 5th root of 4x squared. Number 12, the square root of 13 to the 3rd power. Number 13, we'll have negative 57 underneath, so the 3rd root of negative 57 all to the 4th power. Number 14, 21, 4th root of 21 to the 9th power. Number 15, we'll have the 5th root of 14 squared. Next one, 25x squared goes underneath your radical, so we'll have the 3rd root of 25x squared. 17, we've got the 9th root of xy. And number 18, the 4th root of 12ab to the 3rd power. Page 2, we're going to solve. So remember, solving, you're going to do SADMAP instead of PEMDAS. So we're going to start with subtraction, addition, then division, multiplication, then exponents, and then finish with whatever's inside the parentheses. So for number 19, we're multiplying by 4. So we're going to divide both sides by 4. That gets the cubed root of 5x minus 4 on one side equals 2. We're going to cube both sides. Cubing the cubed root gets rid of that. That gives us 5x minus 4 equals 2 cubed, which is 8. Now we can add 4 to both sides. 5x equals 12. Divide by 5, and we get x equals 12/5. So then now, we can plug that back in and check to make sure that 12/5 is a real solution. Always check your answers, so we're going to plug back 12/5 for x. That's going to give us 4 times the cube root of 5 times 12/5 minus 4. That should all equal 8. 5 times 12/5 is 12. 12 minus 4 is going to give us 8 underneath the radical, so we've got 4 times the cubed root of 8. Cubed root of 8 is 2, so 4 times 2 is 8, which means our answer works, so x equals 12 over 5, or 12/5 is a correct answer. Number 20, we're going to start off by dividing by 3, so we get x to the 3/4 power equals 8. Now we want to raise that to the 4/3 power. You get rid of that exponent by raising it by the reciprocal, so 3/4 to the 4/3 gives us x to the 1st power. On the left, we get 8 to the 4/3 power. We can rewrite that as the cubed root of 8 to the 4th power. Cubed root of 8 is 2, and then 2 to the 4th power is 16. We're going to check our answer again. So 3 times 16 to the 3/4 power. We're looking for the 4th root of 16. 4th root of 16 is 2. 2 to the 3rd power is 8. And so then 3 times 8 will give us 24, so our answer checks out. Number 21, we've got the square root of x squared minus 10 equals the square root of 3x. We're going to square both sides. That gets rid of our radical, so we're left with x squared minus 10 equals 3x. Subtract 3x. Whenever we have a x squared in here, we're going to get everything on one side, set it equal to 0, and now we have to factor. What multiplies to give us negative 10, that adds to give us negative 3. So we're going to get x minus 5 times x plus 2. Negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. Set each of those equal to 0 and we solve, so we get x equals positive 5. And subtract 2, we get x equals negative 2. We're going to plug those back in again to check. Square root of 5 squared minus 10 equals the square root of 5 minus 3, or 5 times 3, I'm sorry. 25 minus 10 is the square root of 15, and 5 times 3 is the square root of 15, so both of those equal each other. That checks out. Now we're going to plug in negative 2 to make sure that works. Negative 2 squared is 4. 4 minus 10 is negative 6. On the other side, we get the square root of negative 6, so now we have negatives underneath the radical, so those are imaginary solutions. So our answer is just going to be x equals 5. Number 22, we're going to square both sides to get rid of the radical. Make sure you FOIL this one. It does not equal x squared plus 9. We're going to get x minus 3 times x minus 3. That equals x minus 1 on the other side. Multiply that out, we get x squared minus 3x. Minus 3x plus 9 equals x minus 1. Combine your like terms. X squared minus 6x plus 9 equals x minus 1. Get everything over to the other side so we can factor again. Subtract x, add 1, we've got x squared minus 7x plus 10. Now we're looking to see what multiplies to give us 10 that adds to give us negative 7. So that's going to be x minus 5 times x minus 2. Set those equal to 0, and we're going to get x equals positive 5 and positive 2. We're going to check those answers by plugging them back in. Five minus 3 is 2. Square root of 5 minus 1 is the square root of 4, so those both equal 2, which checks out. When we plug 2 in, we get 2 minus 3 on the left, which gives us negative 1. Negative 1 does not equal 1, so x equals 2 is an extraneous solution, so our only answer is x equals 5. Number 23, we're going to square on both sides. Once again, since we've got 1 plus the square root of x plus 1, we have to FOIL that. So the left side gives us x plus 3. We're going to multiply 1 plus the square root of x plus 1 times 1 plus the square root of x plus 1. That gives us 1 plus 1 square root x plus 1 plus 1 square root x plus 1 plus x plus 1, since the radical will cancel out. Combine your like terms. That gives us 2 plus x plus 2 times the square root of x plus 1. We're going to subtract our 2 and our x to both sides. We get 1 equals 2 times the square root of x plus 1. Divide both sides by 2. 1/2 equals the square root of x plus 1. We're going to square both sides to get 1/4. And then subtract 1 from both sides, and we end up with x equals negative 3/4. So when you work this out, you get the square root of 9 over 4, which is 3/2, equals 1 plus 1/2. So both sides check out. X equals negative 3/4. Number 24 is similar. We're going to square both sides. We're going to FOIL this one again. Square root of x minus 2 gives us x minus 2 square root x minus 2 square root x plus 4. Subtract our x, subtract our 4. We've got negative 9 equals negative 4 square root x. Divide both sides by negative 4, and that gives us 9/4. Square both sides, and we get x equals 81 over 16. So when we do the math, 1/4 equals 1/4, so 81 over 16 is an answer. For the final page, we're going to graph each function. We've got a couple of cubed roots and a couple of square roots. Remember, for cubed roots, we want the number underneath the radical to become -8, -1, 0, 1, and 8. If you don't have an h value, like we see in 25, then we can just plug those numbers in. If you have an h value where something is being added or subtracted underneath the radical, then we got to figure out which value for x makes it -8, -1, 0, 1, and 8. When we plug those in, we get -2, -1, 0, 1, and 2, but we're multiplying by -1 out there. So you got to make sure to multiply by -1. That makes it +2, +1, 0, -1, and -2. So that flips the graph. Real numbers for domain, all real numbers for domain and range. So pay attention to that negative sign out there. That flips the signs. For number 26, we're doing square root, so we're going to do 0, 1, 4, and 9 underneath the radical. Since we don't have an h value, we're going to use those. -3 is outside of the radical, so that's our k value. That's going to shift it down. That gives us 0 minus 3 is 0. Square root of 1 is 1. Minus 3 is -2. Square root of 4 is 2. Minus 3 is -1. Square root of 9 is 3. Minus 3 is 0. There's our graph. Domain is 0 to infinity, and range is -3 to infinity. For the final two, now we have an a value, we have an h value, and we have a k. It's a square root, so we're going to use 0, 1, 4, and 9. But now, since h is 4, we need to figure out which value for x will make it 0, 1, 4, and 9. -4 plus 4 is 0. So we're going to plug -4 in there. -3 plus 4 is 1. 0 plus 4 is 4. And then 5 plus 4 is 9. When we plug those in, we get the square root of 0 times 0, or -2 is 0 plus 1. Since we have -2 for an a value, our graph's going to be going down now, and it's going to be going down by a factor of 2. So now, instead of going down 1, it's going down 2. It's going down 2 here, down 2 here. And so our graph is flipped. It's shifted over to the left 4 and up 1. Domain, -4 to infinity. Range now goes from -infinity to +1, since we start negative, and go up. To the last one, again, we're going to use negative 8, negative 1, 0, 1, and 8. We want this under here to be those numbers so we can take the perfect cube. It's going to shift it to the right 3. It's going to shift it up 2. So now negative 5 minus 3 is negative 8. 2 minus 3 is negative 1. 3 minus 3 is 0. 4 minus 3 is 1. And 11 minus 3 is positive 8. We're going to plug those numbers in. We get 0, 1, 2, 3, and 4. So now we're going to plot our graphs. Negative 5, 0, 2, 1, 3, 2, 4, 3, and if you had more room, it would go 11, 4. So our graph's going to look like that. Domain, all real numbers. Range, all real numbers.